is not multiplied by a variable. So there's no variables here, but the variable might be in disguise. So for instance, you can have like the number 5, but we could have a variable, but the variable would be to the power of 0, meaning this would just be 5 times 1, which is 5. Lastly, a polynomial is an expression with one or more terms that are separated by a plus and a minus. So like 2x plus 3y plus 7z minus 5. Those are a whole bunch of terms, 1, 2, 3, 4 terms. If we had 3 terms, it's a trinomial, 2 terms, a binomial, or just 1 term would be a monomial. Right, so this is just defining some things about a polynomial. So a polynomial is a type of algebraic expression. The terms are usually written in a certain order where we have like squared first, and then ones that aren't squared, and then our constant terms are usually last. Variables usually go in alphabetical order. So here we have x, y, z, right in the middle term here. Exponents on the variables usually go greatest. So this would be like the biggest, the greatest to none, so least. And the constants usually go last. So those would be like the numbers without variables would go last. So for instance, we have the 3, negative 2x cubed plus x squared plus 4xy minus y squared. So you can put them in order like that. Really, it really doesn't matter. We do like our constants last, but really they could technically go anywhere. But that's just for syntax or prettiness that we like to have it going from biggest to smallest. All right, we talked about this already, a monomial, binomial, and trinomial. Here we're going to try to remember what they mean and make up some terms with the variables, coefficients, and remember putting some addition and subtraction. Okay, so a monomial, number of terms, there's just mono 1. For example, 3x squared. This would be like one term. Or we can say something like 5y. That would just be one term. Or even like just the number 7 would be one term. A binomial has a plus or minus. You see, a monomial doesn't have a plus or minus. Like we could have a -5, but there's not 2 terms. So here we have 2 terms would be like 3x minus 5y. There's 2 different terms happening here. Or 3xy squared plus 5z. There's 2 different terms just separated by a plus or minus, doesn't matter. Trinomial would be 3 terms. Okay, so let's make up 3 different terms. We can have 2x squared plus 3x plus 5. Those don't go together. Yes, they both have x's here, but there's 2 x's here, 1 x here, and no x's here. So they cannot be combined because this has 2 x's and this has 1 x. And when you're looking back at what it says for like terms, they have to have the same variable and same exponent. And a polynomial has 4 plus terms. Yes, these are all considered polynomials, but things that are more than 4 don't have a special name. So negative 8xy plus 3x minus 5y plus 10. Great. These could even have squares on them or not, as long as they're not like terms. All right, so now we're given some examples here. This has 1, 2 terms, so that's a binomial, and it is in proper form, so that's good. When we're talking about proper form, we want to have all the ones that are exponents first. So here, this would be a binomial. It's 1. Well, binomials too. This is just 1. That's a monomial. And yes, this is in proper order. There's no order to put it in. This one, this one's tricky. It looks like 1, 2, 3, 4 different terms, but there are like terms happening here. So those can actually go together. Here we have -5 plus 11 a's. So it's like -5 apples plus 11 apples. Well, that gives us 6 apples. So this is actually 6a plus 9b minus 6. All right, there's 3 terms here. This is a trinomial. And then now this would be in proper order. Beforehand, it wasn't. Again, here there's no like terms. This is 7m4. We usually don't have the 4 afterwards, so we're going to rewrite that in proper order. Same with the m squared, that usually comes first. So again, this is 3. This is a trinomial. There are no like terms, but we don't really write it like that. We like to write it in terms of our square term coming first, then comes our middle term being with just the m, and then lastly we would have the plus 7 being the constant term. And one last thing, again, we're going to, just like we did in cycle 3, day 2, we're going to be scientists and look for the like terms. Okay, so let's go ahead. Anything else with an x? Yes! So 3x and 8x are the like expressions. This one doesn't have an x, this one has a y, so those don't go together. And this one has an x, but there's 2 x's here, so nope, the 2 x's don't go with the 1x. So these are the only like terms. Okay, let's go be a detective here. Which ones go together? Okay, this one has no m's, this one has 1 m, this one has 1 m and 1 n. This is have 1. Oh my gosh, these can go together. 6m and 3m. Does anything else go together? Yep, these two can go together. This one has a 7mn and the -13mn can go together. So again, it doesn't matter what the number is in front. It's all about the variable and the exponent on the variable. All right, this one has 1a, 1b. Oh, there's 1a right here with the 14. So a plus and 14a go together. So if we want to put those together, we'd get 15a's. Anything else? This one's a little tricky. Yeah, this one has an a and a b. This one has a b and an a. It doesn't matter which way they're written, as long as they have 1a and 1b. So these can also be combined like terms to give us 17 ABs. And then lastly, let's look, this one has 2 D's because it's D squared, this one's 1. Hey, there's something else with 2 D's. So 3D squared and 9D squared could go together to give us 9, 10, 11, 12 D squares. Anything else like terms? I do see a like term here. Do you see it? The -6 and the 8 can also go together. If we added those together, we would get +2. All right, that's it. There are some homework. Try it out. If you have any questions, just send me an email or send me a message on Teams. Have a good day. Bye.